Hello, everyone. This is Group25, and we would be discussing how the consumer behavior is affected at clothing stores. What are the multiple factors that affect consumer spending and the consumer behavior at the clothing stores, particularly? Because this is a topic that has long been explored by the marketeers, and still there are many questions that are left unanswered in this domain. So, some of these questions we will explore in our project. So one of our key questions is what influences consumer spending per shopping trip? So there are multiple factors, for example, the ambience of the store, the consumer mood, the temporal effects, and multiple other factors that affect the consumer spending. And what are the perceptions of prices that affect the shopping habits and satisfaction, whether the consumers perceive the prices to be fair, whether the product is overpriced, or whether it is underpriced. How does these perceptions affect the consumer spending at the stores? And the store facilities, for example, there are the changing rooms and how the staff behaves with the customers. These are the factors that also affect the consumer mood, consumer perception, and resulting in how much spending the consumer has on their stores. And lastly, how does the shopping frequency vary across demographics? For example, males and females. How frequently do they visit a clothing store, and how frequently do they make the purchases? So all of these questions enable us to understand factors influencing consumer behavior in Pakistani clothing stores. Moving on to our dataset overview. Our dataset included independent variable, which was the consumer spending, and multiple dependent variables. For example, some of the key variables included spending per trip, perceived affordability, age and gender, customer experience, and frequency of using discounts. Moving on to the dataset overview. So our dataset was completely primary. We collected the dataset, we designed the survey, circulated it around the target audience, and got 150 responses, which was a really great number given the time constraint that we had for the project. And here is a list of all our dependent variables, spending criteria, perceived affordability, and all of the others that are listed over here. And at the bottom, we have our data frame, which shows how each of these variables were responded by the people. For example, we had a Likert scale for multiple variables. For example, its satisfaction, its dressing room, its cleanliness, service, and all of the variables. And the customers had to rate them out of the scale of 10 or the scale of 5, which was then later scaled on for the regression analysis and well. And there were some other optional questions as well. For example, frequency, gender, and where the advertisement was viewed.
Hello, Assalamu alaikum. I'll be going through Ibrahim Murtaza here, and I'll be going through the data cleaning process and exploratory data analysis, the EDA part. So let's start with the data cleaning process. First, we had to clean up the survey data. People answered differently. Some wrote 10K, others wrote $2,500, and some even put ranges from 5 to 6K. So what the solutions we used were that we made all the money amounts the money amounts the same, turned 10K into 10,000 with digits. We fixed time errors, changed 20 minutes into just the number 20. And for answers that we thought were unclear, we just used the mean numbers. Moving on in spending, in understanding the spending patterns and demographic trends. So basically, what we found was that most people, about 70% people, spend 10,000 or less, and we also found out that only about 1 in 10 people spend over 30,000 rupees, as you can see in the histogram as well. And moreover, men spend about 12,400 rupees, while a woman was spending around 10,000 to 10,200 rupees, showing that on average, men were spending more. And we also found out that older people, older shoppers, who were aged 35 plus, spend about 18% more than the younger ones, the ones that were under 25 years old. So moving on to the features of the store that made the customers happy. In facility rating analysis, the most important feature, according to the scale, was clean stores. The cleanliness scored an average of 4.2, and in consideration to dressing rooms, which just scored an average of 3.8, which was the lowest. Moving on to biggest satisfaction boosters, the biggest satisfaction boosters were clean stores and good lighting. And in customers using discounts, 22% higher satisfaction scores were allotted with customers that use discounts, and 15% were more likely to return within a month.
Okay, now, so moving on to the data pre-processing stage. Firstly, we applied data encoding to convert our categorical variables into a numerical format which are suitable for machine learning models. For variables with meaningful order, like say rating scale variables, we used ordinal encoding, ensuring that the model can recognize and leverage the natural order of things. On the other hand, for variables without any inherent ranking or any inherent order, for example, types of clothing, which we asked our survey takers as a question, we use label encoding, simply assigning a numerical label without implying any order. After encoding, we performed feature scaling. This step was important to make sure that features on a different scale, such as age and income, contributed equally to the model rather than letting large numerical values dominate the learning process. This was to make the model sort of more predicted by a range of variables instead just defined by a small set of variables. Moving on to the next slide. We focused on the features selection to further refine our dataset. We used a correlation-based approach, identifying features that had the strongest relationship with our target variable. This helped us in several ways. First of all, it made our model very efficient by reducing the size of the input data, prevented overfitting by removing irrelevant or noisy features, and also made the model more interpretable with fewer variables, and it became easier to understand and explain our predictions using the correlation matrix. Ultimately, focusing on the most important features also helped us enhance the model's overall accuracy. You can see an example of our correlation matrix here, where the more the darker our colors, this indicates a stronger correlation matrix as compared to lighter colors, which indicate a relatively a lower correlation among the different variables. So moving on to Moeez now, who will discuss the machine learning model. Thank you.
Now moving on to the model selection. We chose a linear regression primarily for its transparency and ease of interpretation. In a black box model, we might know the prediction is accurate but do not understand why. With a linear regression, each coefficient tells us exactly how much spending shifts when a single feature changes by a unit. For example, a coefficient of positive 2000 means that a unit increase in that variable predicts an extra of 2000 rupees spent per trip. This level of clarity is invaluable for retailers. They can directly translate this and use targeted campaigns for quantifiable revenue lifts. It turns abstract data into an actionable strategy without having to understand the complex algorithmics used in the model. Let's look at the model performance on our test set. We achieved a R-square value of 0.49, which indicates that the model explains roughly about half of the variance in spending. Our root mean square error is about 5,241 rupees, and a mean absolute error of 4,075 rupees. So on average, we are off by 4 to 5,000 rupees. At first glance, this may seem moderate, but considering that the average spending is about 10,000 rupees, so our prediction error is almost 40% of the mean. Given our limited sample size of about 1,155 respondents and a rightly skewed spending distribution, and the fact that the real consumer behavior is actually non-linear and follows a non-linear pattern, this baseline performs quite reasonable. Most importantly, it provides retailers a starting point for strategic planning. Now on to Mahi.
My name is Maheer Kashif, and I will be discussing the future risks and improvements that can be made on model. Currently, our model is performing by giving us R-square value of 0.49, which shows that there is a significant room for improvement in our work. So first of all, the main problem that we would like to tackle is to increase the training data sample. Currently, we only have 150 responses for the survey that we sent out, but in the future, to get more accurate results and predictions, we would like to increase this number significantly, as a greater size of training data will give us better predictions and the model will be able to learn patterns or relationships between variables that it is currently missing. Another thing that can be done to increase the model accuracy and predictions is to increase the size of the feature set, which can be done by increasing the number of questions in the survey and introducing like more variables so that the model can better capture the relationships between these variables. And for now, we are using a linear model, a linear regression model to predict the values, but in a non-ideal situation, there are always non-linearities present. We would like to use a non-linear regression model maybe, or random forests, or a basic neural network to capture those complex relationships that a linear model might miss. And another strategy that we can use for improvement is to tune the hyperparameters better, which can lead the model to make better predictions and give accurate results. We can look into getting a cleaner or improved data quality, which means that we have reduced noise, we have the missing values filled with actual reasonable answers and not just removing null values. Another aspect of increasing the data quality is to remove the inherent biases that may be present in the data. That could be, for example, a certain age group is more concentrated in the responses. For example, the age group 18 to 24 is giving 200 or 300 out of the 500 responses. That could cause the model to make inaccurate predictions for people of other age groups and not give accurate results. Feature selection is another important aspect that we can look into, which will basically help us identify the most influential variables, which would help us not overfit to the training data and give more reliable results on unseen data. To conclude, while our model is showing an R-square value of 0.49, signifying that there is a room for improvement, we can solve this by collecting more data, by adding richer features, defining our model choices, and focusing on better data quality. And these future directions will help us capture the complex patterns in the data and make accurate, better predictions, which is the goal of our project.